Alrighty, while I'm on a roll, because I actually just got done recording the video for the last uh, week 12. I'm just going to go ahead and do week 13 too, since I have the script ready. So week 13 is plotting residuals and calculating variance inflation factor. And we're gonna use this package called CAR. So if you've never installed that, you're gonna want to uncomment this line 3 and run that. And then run the 3 lines to open those 3 packages, import the data. And yeah, so if you remember when we generated predictions a couple of weeks ago, we added this argument na.action equals na.exclude for the predict function to work. We're still going to need to use that argument again to generate standardized residuals. So if we run our model that we've been using, including that argument, this is actually not the model I've been using, but whatever. And we see that, so I've got, what do I got here? The illegal immigrant feeling thermometer, and as independent variables, I have the party ID variable, a white non-white dummy, the ICE feeling thermometer, Hispanic feeling thermometer, Trump post-election feeling thermometer, and education. I guess I'm all saying that all of those would predict how someone would rate illegal immigrants. And all of those are significant with the exception of education. Actually is not. Now, if we take a look inside this model over here, and I think I walked through this in that other video, we've got all of these things inside this model that we ran that we really haven't done much with yet. The coefficients are in here, residuals, effects, rank, fitted values, etc. There's a bunch of stuff. But these residuals that can be found here in the model are actually not the standardized residuals, which is what we want. So to get the standardized residuals, we need to use this R standard function. If we create a new variable, which I've called residuals underscore M1, and we use this function and feed it the model, then it's going to create a new variable here of the standardized residual for each observation. I'm going to close this. And if we just take a look here, go to the end of the data set and you see, here it is, residuals M1. And notice that some of these are NAs. We have some missing values in this variables. That's important here in a sec. We just want to compare the first few entries of each, the variable we just created, and then the residuals that are in the M1 in the model over here. We see that they're totally different because these are standardized, these are not standardized. Now, to find a count of observations that have standardized residuals that are more than 3 or less than -3, in other words, outliers, we can sum a logical test with those parameters. Because ultimately what we're going to do is exclude those outliers from our data set. You're going to be asked to do that on the next homework, and then also you should be doing that in your final. So this code here does that. It sums residuals, sums observations that have a residual value of less than or equal to 3 or greater than or equal to -3. And there's 5. So 5 outliers in my data. You could have more or less depending on which observations you got. You might have 5, you might not. But then to exclude those outliers, we subset our data. So if you remember, I said the NAs are going to be important here. Notice we had 176 NAs in the residual variable. So that means that we can expect when we subset our data, because it's not going to catch these NAs. I have 1,200 observations in this data set, but in this new subset data set, it's not going to retain these observations, and it's also not going to retain the 5 outliers. So it should be 181 less than 1,200, so like 1,019 or something like that. And here, so this is, I'm creating a new data set called MyData_sub that consists of everything in my data, in which the this variable has a value that's greater than 3, or that has a value that's less than 3 and greater than -3. And lo and behold, we have 1,019 observations. And now if we run this again to count for, to sum any potential outliers, just to double check and make sure we got rid of them, you see now we've returned a 0. So it worked. So now when we run the model, we've excluded our outliers. Your R² should be slightly higher, I believe, is the idea here. So if we do the summary on the model 1 again. We went from 0.4493 to 0.4759. So excluding those outliers did what it was supposed to do. It raised our R² just a little bit. Where were we? Okay, so then the next thing is calculating the variance inflation factor. This is super simple. This is what comes out of the CAR package. And it's just VIF and feed it the model. And it gives you the variance inflation factor for each variable. I forget, since we haven't already had class, and so it's been a year since I have looked at this. I forget what the threshold is for deciding if I think it's like it's got to be really high. It's got to be like 6 or something like that. These are all fine. Nothing to worry about here. And then finally, the function for partial plots is ARPlots. It's also in the carve package. And it's as simple as the VIF function. It's just AVPlots, and you feed it the model. I don't know why I gave it model 1 and not model 2. But and then it just gives you these residual plots, which Rick will be talking about on Tuesday, what these mean. You don't want cone-shaped residual plots, essentially. What the heck? Oh yeah, finally, this is our equivalent of White's test. So last year, I had a really hard time finding a function that would calculate the White's test, which is something that Rick will talk about on Tuesday. And this BP test, which is in the LM test library or package. So if you run this line, I don't think I need to. Yeah, I already had it installed. But if you want to install the package and then open it up, and then run this brush pagan test is what this is called. But I guess this is like similar or the same thing as a White's test, which is again, something Rick will talk about on Tuesday. So really a lot of like complicated stuff that Rick is going to be teaching on Tuesday. But for the most part, the statistical tests are really super simple to do once you've got the models run. Okay, bye.